Today I'm going to speak for about 20-25 minutes about some of the opportunities that are on the horizon over the next 4.5-5 years at the National Research Council. So my name is Rizcallah. I'm the director for the Building Regulations Group at the National Research Council. And the presentation today is going to focus on three primary elements. One of them is a very brief outline of what the national codes are at the National Research Council, and what opportunities exist for you to participate within that national code process. Secondly, we're going to talk about some of the opportunities that exist on the climate change adaptation projects that are going to be underway. And I'll talk a little bit about those projects and highlight some areas that I think there'll be some opportunities for industry and manufacturers to get involved. And thirdly, we'll conclude with how the various groups, whether it's industry, manufacturers, suppliers, can participate in this process as we go forward. So let's start off a little bit with who is NRC and what do we do at NRC. National Research Council is a research and development organization with about 3,500 employees and about 1,000 volunteers. We have offices across the country in just about every province, not just about, but every province throughout the country, and we work in a wide spectrum of disciplines. We've been around for about 100 years. Actually, we have been around for 100 years. We just celebrated our 100-year centennial anniversary. And our primary mission is to basically work with groups, whether it's government associations or whether it's industry, to help bring their products or innovation to market. So what kind of products? We have three primary disciplines within the National Research Council. Whether it's in engineering, life sciences, or emerging technologies, we could be working on a Canadarm one day, or in some divisions, we could be working on cures for diabetes or cancer in other divisions. But what I want to focus on today is primarily what's under the engineering group, the construction portfolio, which is the most relevant to this group here. The construction portfolio has been around since 1947, and there are a number of areas within that construction portfolio that will relate to some of the work of the group here. We have the Building Envelope Center, the Building Envelope and Materials Group, which basically looks at roofing technologies, building envelope technologies, whether it's insulation, cladding, roofing technology, green roofs, things of that nature. And we work with industry and groups to bring in new products and new systems for this application. We also have the Civil Engineering and Infrastructure Division, which looks at materials and designs and improvements to our roads, bridges, etc. Intelligent Building Operations looks at technology, new technologies, high-tech technologies to make buildings more efficient and buildings that will adapt to changing technologies. The Fire Safety Lab, we have one of the largest and best fire labs, I would say, in the country, but also in the world. We do some leading-edge fire studies and fire tests in these labs. We can build 6-story buildings and burn them down, essentially, in these labs to make sure that what we end up putting into the marketplace will provide us with a safe product and safe for occupants and Canadians. The technical testing services, my colleague will speak about that in the next presentation, but it's primarily we can take products and make sure that they've been validated and tested so that they can be used within Canada. The regulators will accept these products. And finally, the Building Regulations Group, which is the one I'm going to focus on in the coming slides. The National Research Council is responsible for developing, maintaining, updating the national building codes. So building, fire, plumbing, energy codes in the country are developed at the National Research Council. These are the codes that are the models that are used by the provinces when they introduce their building and construction codes. So in Alberta, you have an Alberta Building Code, which is taken off of the National Model Code. 95% of what's in that Alberta Code comes to the National Model Codes. In the case of federal government, they actually adopt that National Code in its entirety, and that's what they use. So what is the role of the construction codes in Canada? We know that the construction industry is a $130 billion industry in Canada, and the role of the codes within this construction industry is very important. It actually establishes the minimum level that you have to build, construct, or design to that will be acceptable within the country. How do we actually develop our building codes? The National Research Council itself does not develop the building codes. It's not the staff that sit in the offices that decided, today you're going to be allowed to build this way and going forward, this is what you have to do. It's actually a set of committees. We have independent volunteer members that sit on these committees. So we have CCBFC, which is a commission. This is a body of about 35 people representing industry, regulators, and general interest groups. And they sit and they essentially decide on what we're going to be putting into our codes. So they'll say, for the next 5 years, because our codes are developed over a 5-year cycle, but for the next 5 years, we want to work on energy, and we want to improve energy efficiency in buildings. They'll set that policy, they'll set that decision, and then they send that direction off to the little boxes that you see below, which is the standing committees. Those are the technical committees that have all the expertise. So Standing Committee on Energy Efficiency for Buildings, for example, EEB, is a committee that looks at updating and improving the National Energy Code. Again, it's a committee of volunteers. National Research Council provides financial support, administrative support, and technical support, both at the committee level as well as at the research level. So we will research and provide validation for all the requirements that are going into the code to make sure that it's sound and it will actually work as intended. The system itself is very open and transparent. It's not a closed system. If you're only on that committee and on that commission, you decide what happens within the code development process. Everybody and anybody can get involved in that process. It's open, it's transparent. You can come as an observer, you can put your name down to sit as a committee member, you can actually comment during consultation, and consultations take place every year on the changes, and everybody who comments, everybody who participates is listened to. So this truly is an open system. Sometimes we hear a lot of comments of why did NRC do this, and why is NRC putting this into the code? We put it into the code because the independent body of voluntary committee decided that this was in the best interest for whatever the issue is that we put into the code. Very complicated, very convoluted slide here, but essentially what it's telling you is that there's ways to participate in this system at the beginning, at the end, in the middle, throughout the whole process. So right at the very beginning, if you're a designer, if you're an industry, a manufacturer, and you have a product or a system that you feel warrants application on a national level, you can come to the National Research Council, or you go online on the National Research Council and say, you submit a proposal for change. You say, I have this great system for installation of buildings, and I would like to have this introduced into the codes. The committees will take that application and they will consider it, they'll look at it, they'll weigh the pros and cons of that system, they'll debate it for, it could be up to 5 years, it could be longer, it could be shorter, and then they'll make a recommendation that this change go into the code. So I don't have a pointer, but on the right-hand side, you'll see another opportunity to participate. If the committees get a proposal from a manufacturer or industry or association, and they go forward and they put a recommendation, it may not necessarily look like what the original person submitted, but they will look at that and they'll put a submission out and they'll say, okay, public, comment on this. This is what we're going to put into the code. This is what we believe the benefit is and what the cost is of that change that we're putting into the code, and you're now allowed to comment on it. So people can then come back, competitors, other people that use, other builders can comment on that change. The committees then take all those comments and they do one last kick at the can. They look at the comments, they say, did we get this right, did we get it wrong, and then they'll go back out with a new solution, a recommendation for the code. On average, we put our codes out every 5 years, give or take a few months, but every 5 years a new set of codes come out, and we receive anywhere from 5,000 to 8,000 public comments on our changes. So I've already talked about all the partners in the system, and I'll skip the slide right here. So how does climate change play into this? So I just finished telling you that the National Research Council is a research organization, and we also develop building codes, construction codes. Over the next 5 years, NRC has received funding to work on climate change adaptation requirements for the code, and I believe this is going to open up a lot of opportunity for industry, manufacturers, and designers. So in the area of infrastructure, the National Research Council is going to be looking at introducing new codes, guidelines, and tools to deal with heavy rail, bridges, roads, wastewater, and flooding control. So technology in those areas is going to be required. We'll come in and we'll design and we'll come up with solutions, regulations, and guidelines to do this, but the manufacturers have to have the products that come out to meet those demands. On the infrastructure side, I didn't want to focus very much on it. I'd rather talk a little more on the construction side, on the building construction side, which will be the following slide. This is just an example of what's happening with climate change adaptation. This is a tanker rail in Halifax, or in Nova Scotia, that fell off the track because of tidal surge. So it eroded the ground, and everything collapsed. So this is the type of things that we're going to be designing to try to avoid in the future. Designing against. Some of the opportunities that actually exist on the construction side are numerous. I can't tell you what the opportunities are because we're still in the midst of actually developing those changes and those technical solutions. But if we're looking at opportunities both for new buildings and existing buildings, we're looking at climate change adaptation measures that will mitigate against snow loads, heavy wind loads, variations in temperatures, Permafrost, we have a melting permafrost up north, so we have to come up with solutions to guard against that. Wildland fires, so we've had a number of wildland fires in the past, and we want to try to mitigate or reduce those. Fenestration, electrical and basement flooding issues. So here's the rest of the slides don't have many words on them. They're just a lot of pictures. But if you look at snow loads, for example, historically the way the codes are developed is they look at historical data for climate. They look at what's happened in the last 5, 10, 15, 20, or 30 years with regards to snow loads. So we take that data from the past 50 years, say, and we use that data to determine how we're going to design our roofs, how we're going to design our walls, how we'll design anything that's structurally loaded. Unfortunately, that doesn't work going forward. We know that the climate is changing. We know that there's going to be differences in the amount of snowfall, the amount of rainfall that we get going forward. So we're actually looking at finding and working with various organizations like Environment Canada, for example, to determine what the forecasted 50, 75, 100-year predictions will be for snow loads and wind loads, for example. We're going to take that data, and that's the data we're going to be using when we come back with new requirements for how you build your roofs, what kind of materials you need to use. So if you look at it from an opportunity side, as an industry rep or as a manufacturer or supplier, this is a great opportunity. This is an opportunity for you to say, okay, let's watch what NRC is doing, what kind of changes are coming in the code. Maybe what we come out with is something that says, the shingles that you put on your roof are going to have to be durable to this level, a lot better than we have now, and this will allow you to be prepared and actually have a product that's on the market ready when those new requirements and those new regulations come out. You look at extreme events like wildfires. The latest one we had was in Fort Mac, billions of dollars in loss. They lost almost an entire community because of that. And that has to do with climate change. Rightly or wrongly, if you have drought conditions, you have a lot of lightning, you're going to have fire. And as we build communities closer and closer to wildland, you're going to run into situations where you're going to lose communities because of this. So we're coming up with solutions. How do we build in communities? We're not here to change the climate change. That's not the mission here. The mission is how do we build knowing what's happening as we go forward. So in a case like this, can we come up with products that are more fire resistant? Can we come up with roofing materials that are fire resistant? Building envelope material that's more fire resistant? Can we put sprinklers in these buildings? Are there new technologies or new methods that we can actually introduce that will actually reduce the impact of these these fires that actually happen? So these are opportunities for industry. Permafrost Technology. We know that communities up north that build on permafrost are running into a lot of problems. Problems like this, where the buildings themselves, the permafrost begins to melt in certain areas and the building begins to settle unevenly. We have to come up with solutions and technologies that's going to allow us to build in these communities where there is permafrost and not suffer from situations like this. So NRC is working with various standard organizations and developing thermosiphon standards, for example, where you can actually build, and the thermosiphon standard would allow you to bring in cold air into that ground and keep that ground frozen from the cold air from above to keep situations like this from happening. But there's other technology that can be used, and that's, again, another opportunity for industry to jump. We know it's happening. You might as well jump on it and figure out if you can come up with a solution that we can then introduce either into a standard or into a code or a guide that people can use. Flooding, this is Calgary. We know this happened a few years ago. There's technologies that we can do to look at coastal flooding, river flooding, or inland flooding. And just off the top of my head, if you wanted to look at flooding, you can look at backflow preventers, double check valves entering into a building, sump pumps, emergency sump pumps. You could look at things such as furnaces that don't get destroyed when they get submerged in water. People are designing these. So if you want to get into a market and get into a niche that we believe will be beneficial, this is an opportunity for you. Hail, again, these are not mothballs, but they're actually hail balls. They're causing a lot of damage on roofs, on buildings, on windows. You can come up with products that will actually not get as damaged with the typical products that we're using today. That may be an advantage to some industry groups. Wind load, we're looking at different measurements for wind, and so maybe the application, the way you actually install siding on the side of buildings or the type of material you use will have to change or will have to adapt to these higher wind loads. Same thing with fenestration. I'm ending the presentation in a couple minutes here, but I just basically wanted to end it here by saying that the process itself it involves a lot of groups. So you have the regulators on one side that enforce and tell you what to do. You have the National Research Council that's going to develop requirements for what we want builders, designers, manufacturers to do going forward. But what's very, very critical is the industry itself has to be there. We can tell you to do X, Y, Z, but if industry is not ready to do X, Y, Z, that's all it is. It's a book telling you to do X, Y, Z. So you really need to be working with us, be aware of what's happening on our end so that you're prepared to actually deliver on the products that I think we're going to have to deliver on in the next 4 to 5 years. Okay, so that's it for my presentation. I'm willing to take some presentations, some questions. There's a mic here, I think, if there are any questions. If anybody wants a copy of the presentation, we're located over in aisle 5 or aisle 500, just at the very end over here. And you just come over, we'll scan, and we'll email you the presentation if you're interested in that. Okay, thank you very much.